Hello guys, I want to show you something. I want to show you how I code my single page applications. So there are a few primers to this video. Um, First, the language I'm gonna use TypeScript. TypeScript is a great language. If you haven't checked it out, go on. If you don't like TypeScript, or if you believe static types are useless, you can stop watching this video right now. Second, I will be using a lot of RxJS, so in order to understand what's going on in this video, you really need to know about RxJS. A good place to start is this article. It's really famous, so you should be able to find it very easily, and it will get you started really fast on RxJS. Then Redux. Well, I'm not going to present Redux. You probably have heard of it, but I will be using Redux as a core implementation for state management, so it's better if you understand, so you have some basic knowledge of how Redux works. And what would be really great for you is to know a little bit about Redux Observable, because Redux Observable is a middleware for Redux that integrates Redux with RxJS, and it introduces the concept of epics, and I'll be using quite a few epics in this video. I've actually used this course, which is a great, awesome course by Shane Osborne. He teaches you to use Redux Observable, and I find his example is so good that I kind of stole it and used it in my own way. But if you haven't watched this course, it's probably not free, but maybe you can still watch it. It's great, and if you have watched it, then you're ready. Go on and let's get started. So I've been developing single page applications for something like 9 years, and it's been a long journey where I've tried to find my style. Two things I wanted to achieve were test first. I want to be able to code my applications test first. That's really crucial, and that's really complicated to do in a fast, simple, and efficient way in single page applications. Second thing, I want type safety and no concessions. I don't want any lying around in my code. I really want to be very, very tight in my type safety. So I had to write my own libraries. This is lenrix. It will basically wrap a Redux store and give it a reactive API. Second library is immutable lens. At first it was just a component in lenrix, but then I figured that it could be useful outside of lenrix. It's basically a library that allows you to make deep updates in complex data structures. So if you have a very deep object and you only want to change a tiny little thing deep in the object, and you want to keep all the rest the same and keep the references of the rest the same, that's really important, then you can use immutable lens. So if you are a Redux user, you can already start installing immutable lens and trying it in your Redux app. Basically, it will be like in your reducer. If you have a deep update to do in a reducer, you can use immutable lens. And last, I created my own router. There are a few reasons I wasn't really satisfied with all the routers available. I want my router to be type safe. I want my router to be state focused, say state oriented, and not URL oriented. I'll tell you more in detail about the router in the second part of this video. So, this is the GitHub project that will host the code for this video. So if you if you want to follow along and code as we go in this video, you can already clone this project and check out the start branch. Otherwise, you can just check out the master branch and see the end result and whatever suits you, but this is not required. You can just watch the video and I'll explain each important bit of code. So here, this is the end game. I'll show you how the final application looks like. It's a very simple application, and the most complex part of the app is this search input, because we want to do stuff like debouncing, we don't and canceling, well, all the usual stuff you would do in a search input which doesn't have a search button, but you'll see all the details. What's interesting is that it's a deceptively simple component. It looks very simple. You think you do it very easily, but it can take actually quite a lot of time to really get it right and clean all the bugs. So I'm just gonna use this input. When I type a character, a request is sent. You saw there was a little spinner here, and then I get the results, and I display the results. So also I want to have only a single request if I type a lot of characters very fast. So here you see I only had a single request, stuff like that. And well, that's basically the app. Then I have that will be the second part of the video. I can click here, then I'll show you the URL. Currently I'm on beer search, then I click the beer, I navigate to this beer/ID, and here I'm just printing the JSON object that I received from the API. So please wait, and then when I receive the result, I just print them. So this I'm going to use just to show you how the router works. Okay, so I'm just going to check out the start branch. And now it begins. So we are on this page, and probably I should npm start here, maybe. First I'm going to run my tests and watching tests, and also I'm going to sorry, I need some space. npm run npm start. Okay, so here just wait for webpack. Okay, this is not very relevant. Here, this is the beer search page. It has a URL, and it has all the style and the HTML already here, but it doesn't do anything yet. And if I type, nothing happens. The console is dead, nothing happens. Okay, so what I want to do from here is go in pure TDD. No line of code should be written if there is no failing test. And right now I have no failing test. I have no test at all. So let's write a test. I'm going to go in my beer search page. Beer search, that's my beer search page. And I'm gonna leave the component as it is right now. I'm gonna look at my store and my tests. So well, I'll show you about the folder structure later. Right now I'm going to focus really on my store. Wait a second. Okay, here's my my boilerplate for my tests. For now, I'll just start by saying, okay, maybe in my store what's really interesting would be to catch the event of a search input change. So I'm going to define actions for my component, and that is here. And this actually doesn't do anything at runtime. It's just a way for you to specify the types you want to use. So it's really just giving hints to TypeScript. Say, okay, I want to have this action, which I'm going to call search input value changed. That's the type of the action, and then there's the payload type. The payload will be a string, because an input has a value of type string. So then I can dispatch these actions, and that's what we're going to do in our tests. Let's go. It well, what does it do? Actually, I'm gonna do it like this. When something happens, what happens when search input value changes, and then we're gonna do that input value change event. So store.dispatch the search input value changed, and I'm going to say B. Okay, we'll simulate the user typing B in the search input. Then what happens? What would happen? You could say, well, maybe there's this pending thing here. What value does it have at the beginning? Well, maybe we should make sure that before we do a single thing, this spinner is hidden. So before first action is dispatched, we'll check that initially it initially is not pending, and we expect the store to have a current state with a pending property. Expect to be false. So what's this pending? We don't have the pending thing. Well, we're talking about state here, but what is the state of our application? I'm going to show you how to see the state. As I told you, I'm using Redux as an implementation for my state management, for the core of my state management. So we actually have Redux, and we have the Redux DevTools. So I can just check the state, and here's the state. We have beer, search and detail, and this is actually it reflects the path. I have a beer search page, I have a beer detail page, and I have associated states for each of those states, for each of those pages, sorry. But now the states are empty basically. So let's see what we can do. I'll show you how I define the application state. Here is my app state, and it has its type, of course. It has those well, beer search, beer detail, and then I want my app to be really like how can I tell? Well, I want the structure of my application to be fractal, meaning that I want to be able to take a folder, move it around in my application, and just rewire a couple things, and it should work perfectly. So I don't want everything to be defined here in my app state interface. I want my beer search state to be defined in my beer search folder. Actually, whatever is related to the beer search, I want it to be in the beer search page folder. I want to collocate everything that is functionally linked together. So beer search state will be here, and that's actually that object here. It's my beer search state, and then I can start to type it. I said I wanted to have a pending boolean, and it has to be initially well, it doesn't compile. Let's make it true first to make sure the tests fail. And right now it doesn't compile for a different reason. See here, and now I'm really going to talk to you about lenrix. Lenrix is a wrapper around Redux, and if you know about Redux, it has a mechanism which is called combine reducers that allows you to not have only one big reducer that will handle all actions, but to be able to cut down the state in pieces and then combine reducers, and then you have a state structure that will mimic the combined reducer structure. I don't really like this mechanism because it's I think it's too constraining. So I created my own. Basically, you have a store. Here I call it the App Store. Here it's just boilerplate code so that Redux DevTools work. But from this store, and there's only one store, you need to remember that. This is like Redux. There's a single store in the whole application. However, what you can do is take a store and derive a substore, but it's more actually like a proxy store, focused proxy store, and say, okay, I'm not interested in the whole state, in the whole app state. I just want to focus on a specific part of the state, and that would be beer. So now I'm focusing only on the beer part of my state. So there will be search, there will be detail, and if I want to focus more, I can say, okay, no, I don't care about what's in beer. I want to beer search. And just a note here, beer and search, they're not strings. Like if you make a typo, you'll get a compilation error. They're keys of the state object, and so I'll be using a lot of strings, and they will look like strings, but actually they are type safe. So now our test fails, which is a good thing. Our test fails. Let's comment this thing because we don't want. Okay. So now we have this current state pending to be false, and it's actually true. So that's not good, but it proves that our test works. So now I'm just going to change that initial state to false, and here it goes. Our test passes. Now let's move on. Let's write another test. Cannot read property dispatch of undefined. Why would that be? We have a store. Oh yes, it's because the now it should work. Okay. Here. So I dispatched, but then what happens when I change when I type a character? What should happen? Well, first thing that should happen, we should fetch the results. We should make an HTTP request to the backend or to the API, whatever we're requesting, to get search results. And that's something that should happen. Second thing that should happen is we should have this pending field. So maybe for you to better understand, I'm going to actually show that pending value Right now it's hard coded, so I'm showing it every time, all the time, and I want to hide it when to reflect the store's state. So this is a regular function component. Um, I'm going to to connect it to the store. And how do I connect it to the store? I'm not gonna use it like Redux. Redux uses a custom connector. I'm going to use something that is more standard, that is going to be really part of a JavaScript core. I'm going to use observables. So first, I'm going to get my focused store from my application core. I'm going to show you about the core a bit later when we talk about dependencies. Uh, okay, here's my store, which is focused on really the beer search part of the state. And my store has ways to I have many ways to get the state out of my store. There are synchronous ways like current state. This is really useful for testing. But then you have the state observable. State observable will give you an observable of the focused state. What I really want you to use is either pick or pluck. Pick is great. It will allow you to pick just what you need from just the properties you need from the store, and so that later on, if you add a property to the store, it will not trigger additional re-renders that you didn't want to have. So now I have an observable of an object which has a property called pending, and I'm going to pipe it and this is going to be the state here, and return, well, let's just return this. Of course I forgot the map. Okay, so basically you're piping the store state to some representation of the DOM, and well, an easy way to make it a React component is to use recompose. It's, component from stream, from recompose, and I'm just going to return this whole thing here. And here's my state, and here I'm just going to conditionally display or not this loader based on the pending value. So here the value is false, so that will allow us later to actually see it when the state changes. Here I really like to decompose my state, so here I don't have to have all these state dot etc. So here now that I have connected my my component, I'm gonna write the test where, well, when the search input value changes, first thing that I should do is show the spinner. Say, okay, I'm actually doing this request, so wait for the response. So it is pending. Expect the store to have a current state. True. Okay, good. Our test fails. Great. So how do I make my state update itself when I do something? Well, this is where I'm going to use something I call an update. An update is really like the reducer. It's really like a reducer. It takes the action payload, then the current state, and returns the new state, the new version of the state. So here the payload, it's a string, it's the input value. And here the state, we're just going to return the same state. If you have experience with Redux, I guess you are doing this all the time. And then we're just going to change the pending property of the state, like overwrite pending. This is the 3 points are just going to say, okay, I want the same thing as the previous state, but I just want to overwrite the value of pending and set it to true. Here it's a very simple state, it's flat, so it's still manageable like this, but imagine you have a more complex state that you have focused on. It can become quite cumbersome to always destructure your objects, and you can have many levels of this destructuring. What I like to do is use the lens. So let me just show you what I can do here. The updates, when you okay when you define updates, you can inject a lens, and that lens will be really focused on this state. And you can use lens to do it in a way that I like better. Lens dot set fields, and I want to set the field pending to true. Basically it does exactly the same thing. It just has a cleaner API. For a simple example like this, it might not seem a big difference, but for really complex updates, deep updates, it can help a lot, because this lens can focus very deeply into the state. So here the input value, actually we don't really need. Okay, and the test passes. We can already check here. Doesn't work because of course we haven't dispatched anything from the component. So here's my search input. I'll just get my store. And well, it's an event. This is like simple React code. I'm sure if you know about React, you have written a lot of code like this before. You'll notice that I don't really care about having any here. I consider my components to be uh, less important than my core. My application core, which is made of my stores and my router and my tests, is really where the meat is, where the value is. The components, they should be throwable. They change a lot, they're very volatile, they can be moved around, and well, I write the best code I possibly can, but I don't test my components. I try to make them as dumb as possible. So here there's absolutely no logic, you see. Just when something happens, just dispatch an action, and the logic will be in my store. So here, okay, I got the action, and it it did make the update. So here we're good. Now we're showing the spinner. Also, I want my components to be as dumb as possible, because you never know. One day maybe you'll ditch React and you want to go with a different library or a different framework. Your client might want to use Angular or Vue.js, whatever. Vue, like the component part of the application, should always be an implementation detail as much as possible. I don't test my components. I'm not saying you shouldn't. I'm saying that I'm not working on applications that are critical enough to for it to actually be worth it to test your components. If you work on a big application which has millions of users, yes, of course, you should test everything, your components, you should have multiple levels of testing, etc. I work on internal applications of a few hundred users tops, so it's really not worth it for me to test my components. And as I said, they're so dumb, the risk that something goes wrong is really low. So if we have a bug, it will be a simple bug, easy to fix, and we can afford to have a few minor bugs here and there. So however, my application core, the logic of my application, I want to test it not only because I want to provide the best quality, but also it makes me faster. It makes me a better programmer because it makes me faster. And really, there's absolutely no reason why you shouldn't do something. You shouldn't test drive your application core, because it will make you faster. Maybe it will take you a few weeks or months to get up to speed with the skills you need, but in the end the code will just ship faster, you will write it faster, and the quality will be much better. So now that we've gotten this I said something about dependencies. I said, okay, I want requests to be sent when I type here, and for now no request has been sent. So I want uh, to send my request, and now I'm just going to have to tell you about the core architecture. This is my core folder. It it has the root components for my application core. My application core is something that is pure TypeScript, pure redux, RxJS, lenrix code. There's no React in here, there's no component, no DOM, no HTML. There's not even the concept of a URL. Um, Meaning that my application core will be testable in a classic unit test. I can create a new core, dispatch actions, even navigate, and then make assertions on my state. If you've heard of something like hexagonal architecture or clean architecture, uh, also called ports and adapters architecture, I have those two folders, ports and adapters, and this folder ports is where I put my interfaces, the interfaces of the things I depend on. And it's important that the uh, the the core defines its own dependencies. The implementations are something that are external, but the core defines the way it will talk with the things, the things it depends on that are not part of the core. Here I only have one dependency. It's my beer service. I can search beers and fetch beers, and I use observables everywhere, basically everywhere. My application core, it's here. uh, well, I'll just explain to you this pattern, but because it can be confusing at first. I'm exporting a core that is inferred from the type of this function. So whenever I change this create core function, if I make it to return something different, then my core type will change effectively. And that's a pattern I'll be using everywhere in the application. So it's a bit mind-bending at first, but really after a few couple minutes you understand it very easily, and it becomes natural. So I want this create core function to take dependencies as input and return an object with my app store that will be the root, my unique store. Then this beer object that will allow me to attach focused stores, and the router. I consider the router to be part of my application core. I'll talk about the router later in detail, but right now it's not relevant because we're going to stay on the same page all the time. Okay, my core, so it needs dependencies. In order to make a core, application core, you need to provide dependencies. And in my tests, I provide the dependencies to the core before each test. I create a new core, new application core, so that all my tests are really independent. And let's go and check what's in this create test dependencies. I provide a beer service with a search beers, which returns an observable that never emits anything. So it's just to avoid avoid null pointer exceptions. So what I want to do here is really check that when I change my input value, I want to verify that a call has been made to my beer service dependency and with the correct query string. So it fetches search results. Expect so the dependency here will be let beer service, that's a beer, okay. And we'll expect the beer service search beers to have been called once with exactly the input value. So okay, so my function never that we saw in the in the test dependencies is not a spy. So I cannot check if the function has correctly been called. I have to use a stub from Sinon.js. And I have to make that search beer a stub. Actually, what we want is a spy, but the stub is a spy, so we're good. Expected stub to have been called exactly once with exact arguments b, and it hasn't been. So now we are going to make the store call this function. So if we want to go the strict way and just make sure it really calls the function, that wouldn't be interesting. I want to dive in really directly with epics, and so epics with no, that's actually pure epics because we don't need the store yet. And that would be search input value changed. And here we are going to provide basically a function that takes the payload stream and returns an observable of an action like this. So epics are really a concept that was introduced in a redux observable, and it's almost exactly the same thing here in lenrix. So the search input value change, that's great. Also, I'm going to use another action type, which is search results fetched, and the search results are an array of beers. So that would be, for example, search results fetched and empty result. Okay, so now it compiles, but we don't have called the dependency. And actually we're going to destructure the dependencies because we're going to need that beer service. So I'm just going to show you how I would do this. I'm going to pipe and switch map over test payload, which is an input value, and call this search beers with the input value, and then I have to return an observable of actions. Like I have to return something that is either a search results fetch or a search input value changed action. So I'm going to map it to all the results and search results fetched. So maybe you have noticed there's something weird in the way I dispatch actions. I have this syntax. Rather than an object with property type and property payload, I directly use this object which has a key and a value. The key is the action type and the value is the action payload. The reason is that like most of the time there's really just type and payload, so I got bored of writing those two things all the time. And so this object, I call it an action object, and here it's I return this same action object. So this is really saying that, okay, when I receive a search input value change action, I'm going to call this search beers function with the value. When I get the results, I'll dispatch a new action, which is this search results fetch action. And what's going on here? Yes, okay. One thing you should always do when you return, when you stub your dependencies that return observables, it's better to always return never, because otherwise you'll get this kind of error saying the stub return undefined, and here the results like so search beers return undefined and doesn't work really well here. So here we're good. So it did fetch, and actually we're going to see it here. So it did make a request. It even had the response, but for now we're not doing anything with the response. But can we see? No. Okay. So yes, we had this. Oh, by the way, this is the custom logger, the lenrix logger. So the redux logger, the redux devtools will only give you the actions that will actually update the state, but the lenrix logger will give you updates. So here the state has changed, the epics. So it's the same action, but first it updates the state, then it triggers the epic. And here it's an action that doesn't have any updater, that doesn't do anything, it's just a message. And so it will change to a green update as soon as we code the updater search results fetched. Maybe that's what we're going to do next. So we did fetching. Now we're gonna describe what happens when we receive the search results. So how can we simulate that receiving the search results? So actually this search beers should return an observable of the results. But if we do something like this, we'll have a problem because the result will return instantly. So what we're going to do instead is say, okay, we'll create a subject, and refresh it for every test. Chance. Okay. Now we're going to return an empty subject, but after a while we can simulate the fact that we received something new, and that's what we're going to do here. Receive results. Next. Well, I could put an empty array, but I'd rather not. I'd rather have this, make this little trick so that it's not an empty array. And we'll have the results. And then we check. Okay, now that we've received the results, we should have the results in our state. And that state will be used to display the result. So it's also we want the pending to go away. So let's start with the pending. It is not pending anymore. Expect. Okay, great. So our test is failing. So now we can say, okay, search results fetched. we'll add the updater, the update, search results fetched. Whatever the results for now, we're just set field to false, and we're good. Let's try it here. Okay, once we receive, the pending goes away. And we not only want to make it hide the spinner, we want to store the results in the store. Beers or results. Yeah, results. 2 equal results. But first we need to results. It's an array of beers, and well, I'll just initialize it with an empty array. So see, this is the reason why I didn't want to put an empty array here, because it would have made some weird assertions. You could have false positives if you leave an empty array here. So I consider it a bad practice to leave empty arrays in things that shouldn't be empty. So here, okay, this is the initial value, and we just need to update our state when we received results. So search results fetched, results, and we just set the field results, and here we're good. So okay, search results fetched. The diff will show that we have the results in our state. No, now we just need to connect the component with our state. So here's our beer list. So we already picked pending, now we can pick results, use it in our destructured state, and here I was using an empty array. We'll replace it with the actual results. And here we're good. Oh, you notice that we're still using the 0 static value results.length. So there is a little bit of logic in here, but well, it's not too big. Okay, we're good. So now that we have the happy path, let's try and get all the bugs, because there are still a lot of bugs here. Let me just show you the first one, which is the most obvious. If I just clear the input, and we get an error because the API we're using, which is the Punk API, will get you an error if you make a request with an empty name. So what we're going to do is say, okay, when, and here I want to emphasize something. When you write your tests, you really stay at the same conceptual level as the app. Like um, it's the you don't dig down into tiny details. The abstraction level is the abstraction level that the user is. You basically write your tests the way your user would describe them. That's really important. So when I'm going to write my test, I'm going to say, okay, when I type B in the search input, then I wait for the results to come back. When I receive the results, I clear the search input, and that's the bug. I have it. That's the level of abstraction you need with your in your tests. So that's how we're going to write our test. Same level of abstraction. So when search input value change, okay, and when they're received, so now we've received them, and now we're going to describe the case when search input cleared. Maybe just well, we'll dispatch store dispatch search input value change of an empty string. In that case, what do we want to do? We want to prevent a request to be sent. So we want to prevent our core application core to call the search beers function on our dependency. Expect no, sorry. So it does not fetch search results. And that would be expect beer service search beers not to have been called. We expect not to have been called, but it has been called. So how can we prevent it from being called? There are many ways we can think of it. The simplest way is just, okay, filter the search input value changed actions and say, okay, input value dot flanks should be greater than the 0. So of course, let me just comment this. Problem is here that our we need to clear the stub, because the stub, like the spy, has already been called once. So before each, make sure that the dependency history, like the spy history, has been cleared. So service clear reset history. Okay, now that we've reset the history, we'll try to make the test pass. Now it passes. So let's check here. B, wait, then okay, the request has not been made, but our problem is here that we're look as if we're waiting for an answer and we haven't cleared the results. So we have to write those tests also. It is not pending. Expect store to have pending to be false. So how do we make this pending prevent, like basically every time the search input value changes, it set pending to true, but when it's empty we do not want it to be set to true. So we could make a condition here, say okay, if the input value is true, if it's false, and apply accordingly. But maybe there's another way, maybe there's a better way. In this case, I think we should instead do something like, okay, let's do the simplest thing possible here. So we input value, and okay, if input value has length basically is empty, then we should then do nothing. Otherwise, sorry, what am I writing? Okay. So if the input value do nothing, can I return something like null? No. Okay, we'll just return something that does nothing. So let's keep on writing tests. So if it's not pending, and now we have the results we need to clear. It clears results. Expect store current state to be empty. So, well, let's again do the simple thing. Results, and just clear the results to an empty array. See if it works. Okay, it works. But there are other bugs here, bugs that are more subtle, that you should are quite hard to find actually. Well, for example, Let's try to make a really quick search, and then before the API has turned to return the results, I'll clear the input. So let's type red and then very fast clear. Well, maybe you've seen the zero, like the results to have been cleared, but then before the API had turned to return, boom, I cleared. Then the results came and triggered the search results fetched update. And so really what I would like here is that when I clear, it clears the state, but it also cancels the request. I don't Once I cleared this input, I don't want the results there. They're irrelevant. I want them canceled. So I don't want this update to do anything once I have cleared the search input. So what would be the most simple way to do it is that to write the test. So it's actually simpler than previous. Mm, I So when search input value changes, and then we're gonna skip this part, say the results are not yet received, and we're gonna make another describe another case when search input is cleared before results. Maybe I'm gonna put it down here. Before results are received. And but then the results are received, so received results next. Well, we don't care about this, so just put here. And what happens at this point? It ignores results. And basically ignoring results means that the results will stay empty. So now we're going to make this test pass. And really we have a choice here. We can handle it in the update, say okay, when we fetched, if the current state is an empty input value, but actually we don't store the input value in the store right now, so that would mean we should store it. It might be a solution, but we're trying something else. Notice that what I find really interesting in this approach is that you write your test, and the test is at the same abstraction level as the user. Like just type in the input, wait for results, etc. But then when you try to make your test pass, you're like, actually I have many ways in which I can make this test pass. So what this implies that you have freedom. When you think of your test, you're thinking about, okay, what is it you want to achieve. You don't think of the how. The how is really when you make the test pass, and that's how it should be. And that's really hard to do in single page applications. Usually when you see people testing their Redux applications, for example, they'll be testing their reducers individually, but that's too fine-grained. You want your test to be at the abstraction level of the user, and that will make your tests much much more robust than those tiny fragile tests you'll get if you test your reducers. I can change my mind. I write my tests, then I can make them pass. Then I can change my mind, say, no, actually this was a terrible solution. No, I'm going to do something completely different, and the tests will stay green. You will not have the fragile test problem that so many developers struggle with. And that's really a game changer when you test first your application, when you write tests, when you write automated tests in your application. You really need to have those robust tests that will not break unless the specifications break. The only reason for a unit test to break is when the specification, the logic, the business logic or the interface UI logic changes. But it's when the implementation changes and doesn't change the behavior of the application, your tests should not break. So okay, I've lost myself now. So I want, okay, when the results are received, I do not want to I do not want to store them. So one way to do that is to cancel this search beers request, and it's actually the best thing to do, because canceling an HTTP request means it will not consume resources anymore. So I want to cancel. That's the best thing I can do. And to cancel it, well, I can pipe to take until what? And here I'm going to this pure epics will become epics because I need access to the store, and specifically I'll need access to store action stream. Search input. Well, does this work? Yes, it works. Okay, let me explain this. Here I have this call to search beers. This will trigger an HTTP call to the API. But then I'm saying, okay, if there's an ongoing request to the API, but during this request I get a search input value changed action dispatched, then cancel it. I don't want it anymore. I'm not interested in it, in the result anymore. So that's it basically. Nothing. Well, maybe I should tell you that yes, the action stream here is all the actions in the application, and here's a way to filter the actions on a specific type. And again, this is this is really typed. So like if you screw up, you'll get a compilation error. So that's it. I guess it should work. Let's but then the pending is still here. Have we not expect store current state pending to be false? Okay, so all we need to do, I guess. Okay, we're good. B what? So looks like we're bug free. So looks like the behavior is correct. But if we look at the network and type blonde very fast, you can see I'm really sending 5 requests when I really needed to send only 1. So that's a bit too much. I don't want to send those 5 requests. I only want to send the last one, and I don't want to to overload my API. So I'm going to wait for like 500 milliseconds for the user to stop writing, to stop typing, and then I'm going to send the request. So that's what we are going to write in our next test. So it's basically the same as this one, but there's something that will start to become complex here in our tests, is that you don't want to write a test where you say, okay, wait for 500 milliseconds. That's terrible. If you have tests written like that and your tests are running sequentially, then every time you write a test that says wait 500 milliseconds, it will slow your whole test suite. So you don't want that. And we have ways to avoid writing tests like that. And for that, I'm going to write like we'll keep this whole describe block, the beer search store, but I'm going to copy it, and we'll have almost the same setup, but I want to test here in virtual time. Okay, so virtual time is a way for you to say, okay, do as if a lot of time has passed and all the observables have all the delays have passed. So what I'm interested in is describe the case where you type 5 characters in a row when characters are typed quickly. store.dispatch, first B, then BL. Okay. It fetches search results once only. So we expect our beer service search beers to have been called once with exactly the last string. And okay, here we have a good failing test, which is okay, there are 5 calls, BL, BLO, BLON, etc. So we're good. Now we have to do something more here, but we'll do it a bit later. You'll see why. Here I want to do my debouncing. Okay, say when a search input value is changed, okay, debounce. Let's put it here, for example. Debounce time for, we said 500 milliseconds. And still, it like our test will not work, because basically we would have to do some wait 501 milliseconds for the delay to pass. So we want to use virtual time, and in virtual time you can say at any time, okay, just do like everything has passed. For that we need a scheduler. We'll use virtual time scheduler and new virtual time scheduler. And this scheduler, we can say, okay, scheduler flush, and that's where you say, okay, everything has passed. Just do as if we had an eternity of time passed, and all the delays are gone. But also we need to pass the scheduler to our store, because it will be, we will have to use it when we make the call to debounce. So we can, here in create test dependencies, I can pass dependencies that I want to overload, but I have to specify my scheduler in as a core dependency. So scheduler, and that would be a scheduler like, yeah. And then in my test I can, okay, say use this scheduler, and actually it's a optional dependency. So okay, and now in my store I have my scheduler, and I'll just debounce and pass in the scheduler. Great. Okay, now you'll see we have 3 failing tests. I'll show you where these tests come from. Um, uh, they come from the previous block. See, all the tests we've written before, they expected everything to be synchronous and fast, and they didn't expect for any debounce. So when I was dispatching, okay, a new input value in the previous test, we expected to instantly fetch the results and everything. So I don't want really to rewrite all my previous tests, and in my tests in general, I don't want to really care about, okay, there's delays, there's debounce, etc. So I'm just going to inject a scheduler, which is an immediate scheduler, which kind of flushes it's immediate scheduler it's a scheduler I quickly hacked from the virtual time scheduler. All it does is every time a new delay or a new subscriber is submitted, it will flush everything, so there will be no delay, never, ever. So that way, okay, you'll have no problems, and all our tests pass immediately like before. So you really have those 2 modes, where first mode is, we could say, immediate time, and then there's the virtual time, where you have to manually flush the scheduler to make sure, okay, now 500 milliseconds have passed and the fetching will happen. Okay, now that we've done that, notice that here the scheduler is optional. So in production, for example, or it will be undefined. Only in tests it is defined. The rest of the time it's undefined, and that's cool, because if it's undefined, the bounce time will fall back to the default scheduler, and default scheduler will use real time, and so it should work perfectly in all the other environments. Well, let's try it. So that's it. Only one request was sent. Let's try again. I'll type BL, one request, OND, and then BLOND. We're good. Well, at this point, everything works almost perfectly. But keep in mind that you cannot, at least I cannot, prove that this works correctly. I don't know, maybe some of you guys are better than myself, and you can mathematically prove that the code is correct and there are no bugs. Me, I have no idea. Like, I can only make sure that the bugs that I have found have been dealt with and will not appear again. But depends. Sometimes I've used different approaches in solving this problem, and I've had different bugs, and some which are very hard to see. It's possible that if you change the debouncing delay, you'll see different bugs appear, or if you have very fast API responses or very slow API responses, you'll have different bugs. So all I'm saying is that it's okay to have a bug if it's a subtle small bug. uh, it's okay to have a bug. What is not okay is have a bug, see it, fix it, and then a few weeks or months later the same bug comes back because you didn't have an automated test for it. So really, this is something I cannot live with. So fixing a bug and having no way to make sure it doesn't come back. um, and I hope you will not be able to live with it either. Um, and in a way, the fact that I cannot prove that it's correct, that I can only hope for it to be correct and fix the bugs I see, uh, is what makes this whole programming thing a craft rather than engineering or a science. I'm not a scientist. I craft code. I do a lot of little things. I fiddle with my UI and try to find glitches and try to fix them with my small skills. But we we really need to stay humble here and realize that we're we're just like craftsmen, and I'm not an engineer, I'm not a scientist. um, and so, but it's better than nothing. Like, even if I'm not able to do this, to solve this problem in a mathematically correct way, the least I can do is write all those tests and make sure that the problems I run into have been dealt with, and to provide a guarantee that they are dealt with, and they definitely. And you really should think about this and say, okay, if you're writing code that are not backed by tests, and in this case, like, this is really a very fragile thing, this small input. It's very easy to introduce small subtle bugs, and you're actually, what are you doing? You're just messing with code. You're not doing anything serious. You're just writing a bunch of code, modifying it, hoping you didn't make a mess or made something worse. Especially when you're trying to fix a very small subtle bug, most of the case you will do more harm than good, like, guaranteed on this kind of small component, a small problem. Well, I'm gonna stop right here, and in a second video I'll show you how to use the router. So basically we're going to make those beers clickable, and when we click we move to another page with the details of each beer, of the clicked beer. And I want to show you how the router interacts. The real difference that you'll see is that the router is unit testable. So it lives in memory, and and there's no URL. You can completely ditch the URLs. The URLs are really small implementation details, and you shouldn't think about them. And that's really the difference. And I the reason I wrote my own router is because I wanted to be able to write my tests and say, stay at the same abstraction level again, and say, okay, then in my test I'll just navigate to this page and verify that something happened, or maybe this store has cleared its state, or whatever I want. Because even though the URLs are not part of the core abstractions, the way I see it. The navigation is central in every single page application. Navigation, the concept of navigation, the concept that you have different pages and you move from a page to another page, this is crucial. And I want all the mechanisms that are triggered when you navigate to be unit tested. What I really don't want to do is bind myself to component lifecycle methods like okay, component did mount when this component is displayed, I want to do something. No, the components should not be involved in this. They should be as dumb as possible. If you bind yourself to the components to do to really maintain the orchestration of what should happen in your application and when, then you cannot unit test at the correct level of abstraction. So that will be in the next video. Thank you guys. If you're still here, you're superheroes. Thanks for watching, and see you soon. Bye.